Assalamu alaikum everyone. So lecture number 10, and today we will be talking about communication networks. So and these are the bullets which we will be going through one by one. In the last lecture we talked about packet switching and circuit switching, and in today's lecture we will talk about circuit switching and packet switching in more details, because we have to merge those switching techniques in order to have another methodology. Then we will talk about the advantages and disadvantages offering by those two different switching techniques, and after that we will talk about the classification of packet switching techniques, and these are datagram and virtual circuit. And then we will compare all three different techniques, and finally we will combine circuit switching and packet switching in order to have another mechanism, that is the ATM, Asynchronous Transfer Mode. And after that we will talk about the protocol that is used by ATM and the quality of service mechanisms offered by ATM. So here we have a switching network, and you can see that we have different nodes, and at the core or at the center we have different switches. So all the nodes, or you can say all the nodes at the edges or at the corners, they are connected by the switches that are present within the core of the network. So and if we want to classify the switching technologies, so we have three of them, and we will be interested in two of them, and these are circuit switching network and the packet switching network. So the relationship that we can have between this circuit, that is the wired circuit, and the wireless infrastructure is that as we talked about that most of the time the backbone or the circuit that is carrying the actual services and data between different wireless networks and wireless infrastructure is actually wired, and they are very high speed network. And in order to have better idea about the backbone, we need to grab those different technologies, and circuit switching is one of the technology that we want to grab in order to have better understanding that how the backbone is providing data transmission, data services in order to support the wireless infrastructure and wireless and mobile computing. So here we have three different types of switching technologies: circuit switching, packet switching, and message switching. So we will be interested in two of them, circuit switching and packet switching, right? And then we have further classification of packet switching, and that is we have datagram and virtual circuit networks. So let's talk about the circuit switch network. So here we have, as I have shown, that we have number of switches, and they are physically connected by media, or you can say wires. Connection between two stations is a dedicated path. So this is important, that there should be a dedicated path between one point and the other point, or one node and the other node. But each connection uses only one dedicated channel. So we can have channels on those different media or links. Each link is normally divided into n channels by using FDM or TDM. So we can have TDM, time division multiplexing, and frequency division multiplexing in order to have subdivision of the link into different sub channels, right? Because physically we have one channel, but virtually what we will do, we will divide that channel into sub channels in order to have transmission. So here we have the mechanism that is called multiplexing of a link. If we want to support a link that can link that can connect more than one nodes or more than one station, so we need to multiplex those different stations or onto a single link. So here we have time division, right? Each circuit allocated certain time slots. So you can see that we have different colors representing different time slots. So on the horizontal axis we have the time axis. So different colors are allocated different time slots. So you can take those different colors as the time slots that are being allocated to different stations or different connections. And then we have division in frequency, right? So here we have each circuit allocated certain frequencies. So now we have allocated certain frequencies, so it's the division in the frequency. So you can see that in the time domain, so we have slices them in the rows. So here we have slicing in columns and here we have slicing in rows. So here we have the frequency on the vertical axis, and different colors are representing different frequencies, and we should have a guard band in order to have in order to avoid interference. So these are two different techniques in order to multiplex a link. So before going into more details, we should know what is a communication path. This is important regarding the understanding of those switching techniques. So a path is a route for data to travel between two nodes in a network or travel between two stations in a network. So we can have a dynamic path, right? And we also have a static path. So static path is a fixed path, as we know that whenever we talk about the PSTN lines, so we have fixed lines or dedicated lines from the local exchange to the subscribers place, right? So that is called, you can take it as a static path. Then we can have dynamic path whenever we talk about the routing of data over the internet. So each time you want to access a web page, so there might be a different path for different time. So in case of dynamic path, the path often changes from packet to packet. So maybe I talked about the access as a whole. So even within an access, if you are transmitting a huge amount of data or transmitting a file, so maybe your file is segmented into packets, and different packets are traversing different paths. So that is a dynamic path, and the example is packet switching, where we have segmentation of data into small packets. And then in the static path example is circuit switching, that is I've mentioned PSTN lines, where if we want to make a call, so we have a fixed or dedicated line or static line from our premises to the central exchange, and then to the central exchange to the main exchange within that city, and then from that main exchange to another exchange in another city, and then we will be traversing from that central exchange within the other city to the premises where we want to call, or with callee is residing. So here we have circuit switching network, and you can see that we have mentioned different cities, Lahore, Karachi, and here we have different switches. So you can see that a dedicated path is established in order to have communication between this switch and this switch, right? Circuit is established and maintained for the entire duration of the communication, right? If we are talking about a phone call, so for the whole duration of the phone call, this circuit has to be maintained. So we have different characteristics that are involved in case of circuit switching. So a path between two nodes of communication has to be maintained, first established, and then it has to be maintained throughout the communication or throughout the whole duration of the communication, and then maintain the circuit for the full duration. So this is also important. First we have to establish the path, then we have to maintain it. So here we have some of the advantages of circuit switching. So continuity assured in the order of transmission. So as we know that the circuit switching was actually invented for voice communication, for you can say state away that PSTN lines, although after its invention we have a lot of different mechanisms, techniques, and by using those different techniques and mechanisms we can also transfer other forms of data, but actually it was developed in order to have voice communication. So that's why we have most of the advantages that are oriented towards audio or voice communication. So here we have audio can be transmitted without streaming, and it provides adequate bandwidth for the whole communication, for the audio data to be transmitted, right? So as we have a dedicated link and we have all the bandwidth available, so we don't need streaming. So the overhead is low as we have circuit. First this circuit has to be established and then it has to be maintained, so we don't need any overheads, so they are on the lower side. So alongside advantages of circuit switching, we have also disadvantages of those of that technique. So actually we are wasting a lot of bandwidth, so it means that we are making inefficient use of the path between the two endpoints. Then user can be locked out of the network. Multiple sessions cannot be implemented. So rather multiple sessions cannot be implemented easily, but we can have its implementation, but after adopting certain advanced techniques. And here we have circuit saturation. So you can see that we have a saturation. We can have a saturation at a certain point. So here I have mentioned that we have the saturation at a certain point. So now let's come to its application, the application of circuit switching network. So we can have voice. So as I've mentioned that it was basically invented for voice communication, but later on we have developed most advanced techniques in order to transmit video by using circuit switching. So we have voice video communication, and PSTN is one of its application. So both analog and digital telecommunication lines can be circuit switched. For example, we have ISDN. So let's talk about ISDN in more detail. So in ISDN we have two different types of channels. First one is B channel and the second one is D channel. So B channel is used for data transmission and D channel is used for control of data transmission, So we have two different switching techniques for those two different channels, B and D. B channel, they are actually circuit switched, and D channels, they are actually packet switched. So here we have an example of a traditional circuit switching. So you can see we have traditional PBX. So this is a switch, and we have a protocol support on this PBX, that is SS7, and here we have different phones, or you can say subscriber lines, and you can see that we have the call processing unit and the circuit switching fabric, and we can have different events, for example off hook, on hook, and then we can also have requests to generate progress tones, right? So whenever we pick up the receiver, we can hear the tone, and then when we are trying some number or dialing some number, so we can also have some generated tones, ring back, engage, and we are well aware of those different tones. Switching at the physical layer in the traditional telephone network uses the circuit switching approach. So here we have the example of a soft switch, right? Because rather than having everything implemented on the hardware, we have hardware that is required, or that we must have in order to design or develop a PBX, and rest of the function or the functionality we have coded them and we have installed them onto a PC, and in that way we can have a very cheaper soft switch as opposed to hardware based soft switch, right? So one of the example is an open source soft switch, Asterisk, and that is available freely, and we can tweak it according to our environment. So most of the functions, they are in the software, or they are software based, and we only need a switching card, that is a TDM card, in order to have or convert a simple desktop PC into a PBX, or private branch exchange. So here we have the architecture. We need a media gateway controller, and here we have a media gateway. Supervisory events, so we need to generate different events, off hook, on hook, and then we need to generate different tones, ring back, engaged, instructions to establish switch fabric connections. So the advantage of this soft switch is that we can connect that soft switch very easily into the conventional network, computer network, and we can also have different interfaces, for example Ethernet and some of other different interfaces, right? So here we have packet switching, right? So you can see the packets, they are following different paths. So here you can see one of the packet is traversing from Lahore to Karachi via this path, and then we have another packet that is traversing and that has to be sent to the same destination, Karachi, but it is adopting a different path. So maybe they arrive at Karachi out of order. Maybe packet 2 arrived first, and then after 2 packet first arrived, then we have to have some sort of technique in order to order them properly. So these are some of the features of packet switching. First, each packet may take a different path. So if I go back, so you can see that all the packets, they have their destination at Karachi, and they have, each packet is having a different paths. So may take, so this is not the compulsory condition. So best path is heuristically determined at each node. So the decision is being made at each node that which path has to be followed for its next transmission. So from here to here, so at this node it has to be decided either the packet will be following this path or maybe it can go this way. So each node decides. So here we have some of the questions regarding the packet switching, because in the last lecture we have talked about packet switching. So we also discussed the advantages and disadvantages of the packet switching technique. So here we have to mention what are the advantages and disadvantages of packet switching. So then we have another review questions. Could the internet, that is defined as network of networks, be called a packet switching network? And then the third review question is, how does packet switching help in supporting multiple communication sessions? And then finally, this is a review question number 4. How does a web server support multiple access to its contents? Because whenever we talk about a web server, so it supports multiple sessions. So a lot of people, they are accessing Google, and the Google is hosted on a web server, so a lot of sessions are being made at the same time or simultaneously. So how does a web server support multiple access to its content? Explain in terms of packets that travel from the web server to their various destinations. And then this is review question 5. What are the implications of packet switching to the transmission of audio and video in real time? So if we want to make a call and the infrastructure, it is packet switching based, so what are the implications? Because we are talking in real time. On the other side, the receiver is also receiving in the real time. So what are the implications of packet switching in terms of real-time communication? And if we want to resolve, if there is some problem, right, and we want to resolve the problem, then how we can resolve it? And streaming in is one of the way in order to resolve the problem mentioned above. So here we have some of the advantages. So as we are asked to mention the advantages, so we can utilize the network segments in a better way, and we have the ability to engage in multiple communication sessions. So we can have multiple communication sessions when we talk about the packet switching. So here we have dynamic assignment of paths. So as I've mentioned, that each node will decide accordingly that what should be the next path. So if the packet is here at Lahore and has to go at Karachi, so for example it is here, right, and from here this node will decide either it should adopt this path. So maybe there is a congestion over here, a lot of traffic already that there, so it can choose another path from here Islamabad to Karachi. So here we have support of multiple sessions. So you can see we have different colors. So one session is in red, and then we have another session in different color. So we can have multiple sessions of communication. So let's talk about the disadvantages. So packets may not arrive at their destination in order. So as you see that if we have two packets that has to be arrived at Karachi from Lahore, so this path looks like a shorter path, so packet 2 will arrive earlier than packet 1 because this path is, it seems like that it will take more time, right? But we do not know the bandwidth, the capability of the link. We are only talking about the distance it has to traverse. So this is one of the disadvantage, that the packets, they may arrive in different order, right? And then the possibility of arrival of packets in different order as they were transmitted exists because of different paths that are taken by different packets. So here we have packet 2 may arrive earlier than packet 1, so that's the same. And then of course at the destination at Karachi we have to reassemble those packets, so we need a technique in order to reassemble those packets so that we can retrieve our original data. So here we have mentioned 2 packets, so maybe if we have more packets, so we have to reassemble them to preserve the order of transmission. And then packets arriving earlier are held in a buffer. So for example, here we have received 2 packets, and this is not the complete data. So now we have to bundle those packets into one data, and then after that we have to transmit them again on the basis of packet switching. So here we have to use the buffer. So we will be waiting for the packet 1. As soon as packet 1 will arrive, so we will be buffering the packet that has arrived a bit earlier. So the order of arrival is critical here. In certain cases the order is time sensitive as well. So here we have some of the problems that are associated natively with voice and video communication. So if we talk about voice and video communication, they are very sensitive regarding the quality of service. So we need timely arrival of packets, right? So how we can overcome those different shortcomings, or we can provide a very effective quality of service in order to have voice and video communication by using packet switching. So what we can do, we can make sure the orderly and timely arrival of data packets by using streaming. Streaming also compresses the data to minimize the bandwidth requirements, thus ensuring that the packets have adequate bandwidth to travel to the destination in the order in which they are supposed to arrive at the destination, right? So this is one of the solutions in order to overcome the problems that we have in case of packet switching based voice and video communication. So we can also have buffering in streaming. Streamed audio or video is often buffered to ensure that the audio or video is played continuously. So whenever we talk about or we want to access a video over the internet, so you can see a delay. So that delay is actually due to the buffering made during streaming. So here we have some of the advantages and disadvantages of packet switching. Efficient use of the network paths, and then we have engage in multiple sessions. We can have multiple sessions by using packet switching. And then the disadvantages includes we need extra hardware and software. So if we want to declare a buffer over our router, so we need some more memory. And if we want to order the packets that arrive in different orders, so we need some sort of technique, and that is probably a software. So we need hardware and software resources in order to assemble and route the packets, right? So as if I talk about this node, so at this node packet has to be transmitted by using this path or by using this path, because we have only two possible links or possible routes. So we need routing capabilities over here also, because it can have, in this case, for example, if here the node has to decide, so it has three paths, so the node should have the routing capabilities. So that can be considered as one of the disadvantages, that we need extra hardware and software resources in order to have packet switching. If real-time continuity is required, then data must be subjected to a process known as streaming. So we need to have or implement streaming. So one of the example is voice over IP. Okay, so now we are in a position to answer the questions, review questions, so that we already discussed advantages and disadvantages of packet switching. And yes, we can take internet as the packet switching network, because a lot of the circuitry that is actually based on, except the backbone or the networks that are actually the one leg of that network is connected to the internet, but most of the part of that network is kept private. So we have a lot of scenarios like that. So we can take internet as the packet switching network. So how does packet switching help in supporting multiple communications sessions? So we have also target that issue, right? And then we have also implications of packet switching to the transmission of, so the delay or the arrival of the packets in different order, or so maybe different packets arriving at different orders. So we need we can have streaming, and we can also buffer the data. So these are the different implications and their solutions. Okay, so this is the answer. So here we have the applications using multiple sessions, sharing, collaboration, multiple access to an internet server or web server. So here we have the wholehearted comparison of packet switching and circuit switching. So if we talk about the packet switching, it's efficient use of network, right? So inefficient use of network, because we need to have a dedicated link between two endpoints, two stations. Then we will be having the we will have the communication. So maybe the link that is dedicated, that is not being used fully, right? So it's inefficient use of the link. Then high overhead, because we are segmenting the data into packets. So of course we need control information, we need to add overheads, or we need to add control information. So it includes overheads, right? So here we have no segmentation, so dedicated link is established and maintained for the whole life of the communication, so low overheads. And the application computer data, audio, video, so we can also only have audio and video transmission in circuit switching, but in packet switching we also have audio, video and data transmission. So in case of packet switching, multiple sessions are possible. In case of circuit switching, multiple sessions are again possible. So we have talked about circuit switching and packet switching, their advantages, disadvantages, and we also targeted some of the review questions regarding those two different switching techniques. So we here will be classifying packet switching into more techniques, right? So you can say that the packet switching can be classified further into two different techniques, and these are datagram network and the virtual circuit network. So if we talk about the circuit switching, so as mentioned that it was designed for voice communication. The packet switching on the other side was designed in order to have data communication alongside voice and video, right? So if we talk about the packet switching, so the data or the services or the whatever voice, video or data services, it's actually is transmitted in small packets, and the packets actually contain the actual data and the control information in order to transmit that data to the destination and then reassemble that data into the original data or the original messages or voice or video whatsoever is there. So we have packets that are received, so we normally use different techniques in order to overcome the shortcomings. For example, the arrival of packets in different order, and then after that we have delay, right? And we can use streaming techniques. We can also define buffers in order to overcome the problems that we encounter in case of packet switching. So then we have further classification of packet switching, right? So in order to have better communication by using the packet switching technique, right? So those two different approaches are datagram and the virtual circuit. So in case of datagram, each packet is treated independently with no reference to packets that have gone before, right? So each packet will be treated standalone or independently. So each node decides for the next route or for the next node independently, right? So packets can take any possible route. So as a result, the packets, they may arrive at the receiver out of order. So this is for sure that if each node is deciding independently, then the packets has to be arrived out of order. So as a result, we can have missing packets, right? And so we have to retrieve, or we have to resend those missing packets, right? So there are different mechanisms, first to detect that there is some packet missing, and then to send a request to the sender that please send this packet again, right? Okay, so here we have the example of the datagram, right? So you can see that we have 3 packets, right? So each packet is adopting a different path. So the nodes involved in the path, they decide independently from the other packets, right? So here, for example, this node will decide that if packet 3 will go here or here, right? And at this node, it has to decide that the packet 2 which will arrive, then the next route will be here or here. So you can see that the arrival is out of order. In case of virtual circuit, a pre-planned route is established, that is virtually, before any packets are sent, and then after the route is established, all the packets, they follow the same route. So each packet contains a virtual circuit identifier instead of destination address. So this is the difference, right? And each node on the pre-established route knows where to forward the packets, right? So they know beforehand. The node need not to make a routing decision for each packet. And some of the examples of those virtual circuit types they are ATM, frame relay, and X.25 communication. So here we have virtual circuit. So before the actual communication start, we have a virtual path that has to be established between the source and the destination, right? So here we have the source and here we have the destination, and virtual path is established, and after that all the packets, they will be following the same path, right? And as mentioned that here the destination address is not important, but the virtual circuit identifier, because when we are establishing this virtual circuit, so we are actually defining an identifier that is correlated with this virtual circuit. A route between stations is set up prior to data transfer, right? All the data packets then follow the same route, so all the packets, they has to follow the same path. There is no dedicated resources reserved for the virtual circuit. Packets needs to be stored and forwarded. So it means that we are actually using circuit switching virtually, but actually we are following packet switching. No resources are dedicated beforehand. So whenever the resources will be free, then the data has to be sent. So it means at this node, if there are no resources, the data will be stored and then forward, store and forward. So we can take the example of an email regarding a service on the internet. So here we have compared virtual circuit versus Datagram. So in case of virtual circuit, a network can provide sequencing. Packets arrive at the same order. So you can see that the packets, they are arriving in the same order. And the error control, we have the error control retransmission between two nodes, because we have established a virtual circuit between the source and destination. So in case of errors, the packets are easily recovered. So then we have quick forwarding of packets based on the virtual circuit identifier. No routing decision has to be made because we have a virtual path between source and destination, so there is no decision making at the intermediary nodes, right? So it's less reliable. For example, if one of the node is failed, then the whole path will fail, right? Because we don't have any other choice, as in case of pure packet switching. Datagram, we don't need any call setup, so no need of setup time, good for bursty data such as web traffic. More flexible, so if one of the node is failed, so it can have other choices, so the data can be sent from here. If this node fails, for example, so we have this choice, right? Or this node fails, we have this choice, or then if this node fails, then we have. So there are a lot of different choices in case of Datagram. Routing can be used to avoid congestion, right? So we can use routing. So here we have the event timing of circuit switching, virtual circuit packet switching, and then Datagram packet switching. So you can see here we need call requests, call setup in case of circuit switching, because we need to establish a circuit before the start of the actual data transmission. So we need to set up the circuit, right? So you can see call request signal, then here we have the propagation delay and processing delay. Call accept signal, right? So here calling and it's accept, and now the actual data starts here, and then acknowledgement is sent, right? And the resources are free after the circuit is disconnected. So here in case of virtual circuit packet call request, so again we need to establish the virtual circuit, so we need a setup time, right? But the advantage of this virtual circuit packet switching is that we have packets, so small chunks of data is being transmitted, right? So here we don't have any setup time, so straight away we will be start communicating the data which is in the form of packets. So here we have the whole comparison between circuit switching, Datagram packet switching, and virtual circuit packet switching. So dedicated path is required in case of circuit switching. So in case of Datagram, no dedicated path is required, so no dedicated path is required, right? So as you can see, in case of virtual circuit, so although we have mentioned that the circuit has to be established, virtual circuit, but so we don't need a fixed path, right? So we can establish the circuit through this way, or there can be different possible way to establish the, so no dedicated path is required in case of virtual circuit packet switching. So continuous transmission of data, transmission in packets, and again transmission in packets. Fast enough for interactive communication, fast enough for interactive communication. So these are the comparisons, and you can go through by yourself. So as we have already discussed a lot about circuit switching, Datagram packet switching, and virtual circuit packet switching. So here we have an issue, right? So as I mentioned that originally circuit switching was developed for voice traffic, and the packet switching was invented in order to support data services alongside the voice services and video services. So what if we need to transfer a converged data, right? A session that includes both voice, video, and data communication, and one of the example is multimedia, right? So one-way batch web traffic, two-way batch voice messages, because it's two-way communication, one-way interactive M-bone broadcasts, two-way interactive video conferencing. So in that case, what we have to do, right, because we have to ensure the quality of service requirements, so those services, for example video conferences, they are affected by jitter, delay, and packet loss, right? So because we have all sort of communications, for example if we are having a video chat, right, so we can also send and receive files. So we have all three different types of data communication: voice, video, and data, right? So in that case, what we should do, right? So the issue can be resolved by having some of a different communication technology, and that is one of the communication technique or technology is ATM, that is Asynchronous Transfer Mode. So actually what we did over here, we have merged circuit switching and packet switching in order to have support for high quality of service sensitive data communication. So connection oriented, high speed, low delay switching and transmission technology that uses short and fixed size packets, and those packets, they are actually called cells, in order to transport information from one point to another point. So is originally the transfer mode for implementing broadband ISDN, BISDN, but it is also implemented in non-ISDN environments where very high data rates are required. So as I have mentioned that in case of ATM we merge switching multiplexing technology that combines the benefits of circuit switching and packet switching, right? Okay, so why it is circuit switching, right? Because it establishes virtual circuits for communication, and at the same time the established virtual circuits, they are actually established over the packet switch network, right? So you can say that at the base we have the packet switch network, and over that packet switch network we establish the virtual circuits in order to have the circuit switching. So that's why I mentioned that we combined packet switching and circuit switching in order to have this communication technology. So here we have mentioned the advantage, that is we can use bandwidth in most effective and efficient way, right? So ATM can be deployed from small LANs to very large WANs, and that is from megabits to gigabit per second data rate transmission, right? So here you can see that we have better advantages of bandwidth utilization, right? So ATM efficiency, so as it's an asynchronous technology, so in case of communication we have two links, one is the uplink and the other is the downlink. So if we talk about the uplink, so you can see that whenever I'm accessing the internet or I'm web browsing, so my request will carry very little amount of data, but on the other side my downlink will be having a lot of data, right? Maybe bursty data. So in that case ATM is very efficient because it can accommodate accordingly. If the uplink needs less bandwidth and the downlink requires more bandwidth, so it adjusts accordingly, right? So that's what has been mentioned. Case of ATM's efficiency, link based on the need for information to be transmitted, right? So cell basics based on fixed length cells. Compare this to the other packet switching technologies such as frame relay, right? There was a very big dispute between US and Europe when they were deciding for the cell size regarding ATM, right? So the US, they were asking for 64 octet, and the Europe on the other side they were demanding to fix 32 octet for the ATM cell, and later on they agreed upon 53 bytes for one cell, and those 53 bytes are 53 octets. 48 bytes are used as the payload, and rest are used for the control information. So 48 bytes and 5 bytes. So we have a header that is the control information of 5 byte, and this is the actual data payload. So here are some of the advantages of fixed length cell. Delay or latency is significantly reduced, right? Fixed length cells make it easier to switch data across multiple networks, right? ATM networks are built based on switches and not routers, right? So we don't need routing, we require switching. Container-based road transportation, right? So here we have the ATM protocol, that is ATM adaptation layer protocol, right? So you can see voice, we have digitized that voice, and then we are using AAL, right, in order to have cells, and each cell is of 53 octets. Video A to D conversion, we can have frames, compression, then compressed frames, and then after AAL we have cells, and again for the data we have the same mechanism. So here we have the ATM model, and you can see that it relates to the two lower layers of OZ reference model, right? Data link and physical layer. So then for each and every switching or routing technique, we have to ensure the quality of service, right? So in case of ATM, this is also one of the key factor that we have to make sure that the quality of service is being taken into account, right? So one of the advantage of ATM is that it is able to offer a specified quality of service. So we have a specific and specified quality of service, can guarantee to their customers so that end-to-end latency will not exceed a specified level, right? So the numbers are provided to the end customer and user beforehand, and they will be complied to, right? So here we have quality of service techniques or mechanisms offered by or supported by ATM. First one is constant bitrate, then we have variable bitrate, unspecified bitrate, and available bitrate. So first of all, constant bitrate. So it's you can say highest, or let me say it, a gold category, right? A constant bandwidth is available for the virtual channel, right? And it's suitable for time sensitive communication. Then we have variable bitrate. So this is at second level, grade B, or you can say it's a bronze, silver. Rather than bronze, it's silver, divided into categories: variable bitrate non-real time, and then variable bitrate real time. All right, so we have different quality of service mechanisms. Available bitrate, right? So that is the grade C, or here we have the bronze, right? So unspecified bitrate, and these are the enforcement mechanism. We can have traffic contract that is very close to the SLA, service level agreement. Then we have traffic shaping. We can also have relate this to the int-serve and diff-serve, where the traffic is classified on the basis of class of services, so, and shaping, right? So how ATM works? So you can see that we have a user application at the top, and that application actually can have, for example, in case of a video conference, right? It have voice and video, but in the same session the users are exchanging files also, right? So maybe a Word file or maybe a text file. So they all will be, right? So here we have segmentation, multiplexing of voice, video, and data, right? And then we have the switching, that is the ATM switching network. And then after that we have the same process but in the reverse order. Here multiplexing, demultiplexing, here we have segmentation, here we have reassembly, and then the user application on the destination side, it will be having the video conference, and if they are exchanging files, they will be able to have data. Right, so that's all. We talked about circuit switching and packet switching, and those switching techniques, they play a very vital role when we talk about the backbone of a wireless communication infrastructure. And then we talked about the advantages and disadvantages of packet switching and circuit switching. And then we also discussed the requirement for some other technique in order to support voice, video, and data services all together onto a single network, right? So we then mentioned ATM, right? and the flexibility offered by ATM, right? As we mentioned that when we are accessing different services, so sometimes we need a higher download link, or sometimes we need a higher side uplink. So ATM can have the flexibility in order to adjust the requirement of the service, right? So, and after that we talked about the architecture of the ATM, the cell size, and the protocol it support. Then we also mentioned the ATM over the OZ layer, and finally we talked about the quality of service mechanisms supported by the ATM, and the methodologies adopted by ATM in order to enforce those different quality of service mechanisms. So that's all. आज के लिए इतना ही काफ़ी है. अपना ख्याल रखिएगा. मेरी तरफ से अल्लाह हाफ़िज़. अस्सलाम वालेकुम.